Today we're graphing in intercept form. Boy, oh boy, is that fun. Here we go. This is what intercept form looks like. You'll see some parentheses usually, and we're going to graph intercept form using intercepts. It's going to give us the x-intercepts where it crosses the x-axis. So we've seen some of these things before. The A is like, shows a stretch or compression, and it's always going to be out in front. Now in this one, there's an invisible 1 out there. And remember, when the A is positive, that's going to make a normal U-shaped parabola. So to answer this question, will it open up or down, we know that just because A is positive, it's going to open up. And when it opens up, they might ask if the vertex is a minimum or maximum point. Every time it opens up, the vertex is a minimum coordinate. Now we know for all quadratic equations that the domain is going to be all real numbers. We could fill that out. And then the range is the y's, so that's not all real numbers. We have the low end, and because this opens upward, the low end is going to hit our vertex. So we don't know what that is yet, but it's going to hit a number. And then the upper limit, it's going to go forever towards positive infinity. So we already have a lot of information filled out just knowing that A is positive. Cool, moving on. I see P and Q. Those are going to be the same thing as the x-intercepts. So that comes from what is with the x. And I think it's easier to think of like, it's always the opposite of what it appears. Kind of like when you graph in point slope form. So if I see x plus 4, my P is going to be negative 4. Which means the x-intercept is going to be negative 4. Now, what that means is like, if I put in negative 4 for x, negative 4 plus 4 creates 0. We're looking for zeros on the graph. But it's easier if you just think like opposite of what it looks like. I see x minus 2, so it'd be positive 2, because 2 minus 2 is 0. So again, that's also going to give us our x-intercept. So we're going to plot our x-intercepts. The x-axis is the flat one. It's going to cross there at negative 4, and it's going to cross at positive 2. Great. Oh my goodness. That wasn't even too bad. The cute thing about this form is the axis of symmetry will always fall right in the middle of those two intercepts. So a lot of times you'll be able to eyeball it. You could be like, okay, this is right in the middle of those 2 points, and that's at negative 1. So you can use that, but it's not always going to be super easy to do with your eyeballs. One side might be 17.2, the other one might be negative 11.186. I don't know. I can't find the middle. So what you always have as an option is you can take the two intercepts, add them together, and then divide by 2. That'll find the middle of them. It's like finding the average, right? So negative 4 plus 2 is negative 2, divided by 2 is negative 1. That's the proper way that you can get the axis of symmetry to be negative 1. Cool. And just like in standard form, the axis of symmetry is also the x-coordinate of the vertex. How we found the y-coordinate of the vertex was you substitute that x in to the original equation, you solve it, and you get your y. So if we put that in for the x's here, we're going to have y equals x plus 4, so negative 1 plus 4, times x minus 2, negative 1 minus 2. So negative 1 plus 4 is 3, negative 1 minus 2 is negative 3, and I'm going to let you in on a little secret here. Those are always going to just be opposites of each other. They're always going to be the same number, but one's positive, one's negative. 3 times negative 3 gets you negative 9. So that would be the corresponding y-coordinate for our vertex. Negative 1, negative 9 is down here, and then we can go ahead and draw our parabola from there. From the vertex through those coordinates, and this is a U-shaped graph. I did the best I could. The only other thing I need to fill out from before is the range. The low end happens at that vertex. It goes down to negative 9 for the low end of the range. Hey, we got one in our belt. We're going to find the intercepts. We're going to find the middle for the axis of symmetry, plug it back in, and our graph is done. Let's try it. Here we go, number 2. Okay, in this one, I see the A out in front is negative 1/2. Anytime that A is negative, that means it's going to open upside down, right? It's been reflected. And when that happens, our vertex is at the top, which means it's a maximum point on that graph. Domain is always all real numbers. Range, if it's opening upside down, it's going to start with the lower limit at negative infinity, and it'll max out at the vertex, which again, we don't know yet. Cool, let's keep it going. Our P and Q are intercepts. I see x plus 2, so I know it could be negative 2. I see x minus 6, so that'll be positive 6. Go ahead and plot your x-intercepts on your graph. Negative 2 is over here. Positive 6 is over here. Now, you're smart. You could probably find the middle of those points. But I do want to practice if it is something that you just can't easily find the middle of. So we're going to add them together and divide by 2. Negative 2 plus 6 is 4. Divided by 2 is 2. So that'll be our axis of symmetry and also the x-coordinate of our vertex. Positive 2. As soon as you find it, substitute it back into the original equation. Let's see, negative 1/2. We're putting in 2 for x. So 2 plus 2 and 2 minus 6. 2 plus 2 is 4. 2 minus 6 is negative 4. If we did 4 times negative 4, it'd be negative 16. And negative 1/2 times 16, negative times negative is positive. Half of 16 is 8. So our vertex will be at 2, 8. And then we're ready for the parabola, baby. Look at that. Give yourself a quick check. My parabola opens down. Earlier, I guessed that it would open down from the A. So that's just like, sometimes kids will graph it. They'll answer these questions first, and then they'll graph it, and somehow their parabola is opening upside down, and they don't check their work. So if you noticed right away that it's supposed to be going down, and your graph is up, you're like, oh, I made a mistake somewhere. But here we go. We got 2 down. Now I'm going to throw a curveball your way. You ready for this? Oh my gosh, y equals 2x times x minus 3. The curveball is with that 2x. So the A is still 2. It's positive, which means that it will open up, which means the vertex will be the minimum point. We know domain is all real numbers. And if it's the lowest point, we're going to put bracket, whatever that y coordinate is, and it's going to go towards positive infinity. We could tell all that stuff just from the A. The P and Q. Now the x minus 3, you're like, okay, that's 3, no big deal. But the x, when it's just an x solo and it's not being added or subtracted with anything, it's going to be 0, right? Like, they're not going to write parentheses x minus 0 because that would just be x. So when you have an x and there's no plus or minus with it, it's going to give you an intercept at 0. So our intercepts are 0 and 3. We have to find the middle of 0 and 3. Now, again, this one, you can kind of just look with your eyeballs. Right in the middle of them would be here at 1.5. 1.5 is the axis of symmetry. It is also the x-coordinate of the vertex. If you could not figure that out, just like I said before, you can add them together. Divide by 2, that would be 3 over 2, which is 1.5. That is the proper way to find the axis of symmetry. Now we do need to substitute that 1.5 in the original equation, so we'll have 2 times 1.5, and then 1.5 minus 3. 1.5 minus 3 is negative 1.5. If you want, you can multiply these in any order. 2 times 1.5 is 3. And I could do 3 times negative 1.5. I think of 3 times 15, that's 45. So this would just be negative 4.5. So we have 1.5 and negative 4.5 might be about there. That's going to be the lowest point on our graph for our range. And then we could just make it a parabola. Whee! Wow! Fun! I have one more that we're going to graph together. And then we're going to look at graphs that are already done, and we're going to see if we can write it in intercept form. Here we go, number 4. Ooh, what's A? Well, I see a negative out in front, but I don't see any numbers. I know that means A is -1, which means it's going to open upside down, which means our vertex is a maximum coordinate. Our domain for every quadratic equation is all real numbers. And our range, it's going to start at -infinity, and it's going to max out at the vertex. Not sure what number that is yet. All right, the rest shouldn't be too bad. P, I see x plus 7, -7. Q, 4, -4. So give yourself an intercept at -7 and -4. Again, you could kind of eyeball the middle here for the axis of symmetry, but let's pretend like that made me a little nervous. So I'm going to add them together and divide by 2. So that would be -11 divided by 2, which is -5.5. That'll be our axis of symmetry and also the x-coordinate of the vertex. 5.5. Just like we have been doing, we're going to plug it back in. Y equals -5.5 plus, plus 7, and -5.5 plus 4. -5.5 plus 7 is 1.5. -5.5 plus 4 is -1.5. So this would give us -1.5 times -1.5, which comes out to 2.25. Boop. -5.5, 2.25 is about there. And then go ahead and drop in your parabola. Nice. We did it. Oh, I need that 2.25 for my range. That's as high as it'll go. Great. We did a great job with that. Are you ready to write some equations for lines that are already graphed? I can't hear you. Oh, okay. Calm down. All right. Ooh. Now remember, we're going to need an A, and we're going to need the 2 intercepts. So A is, once you find that vertex, it's how far do you need to go up until you go over 1. Now this one is obviously going down, so how far do we go down before we go over 1? Here's, if I go over 1, I'm in this column. So where does it hit? It hits right there. So that's down 2 over 1. So we're going to say our A is going to be the -2. I see it crosses at -3. That'll be pretty important. And it crosses at +1. We're ready to go for the equation. Y equals our A, -2. And then in parentheses, we bring in the intercepts. It crosses at -3. It's always going to look like the opposite. So we're going to write x plus 3 for that. Crosses at +1, so I'm going to write x minus 1. Whoa! So much fun! Look at us, ready to go. Number 6, we're going to figure out the A. From the vertex, how far do we need to go up before we can go over 1? If I go over 1, I'm in this column here. So how far did I go up before I hit that column? Just 1. So our A is 1 on this one. I see that it crosses at 0 and also -4. Okay, so we have the 1 out in front. You don't need to write the 1 out in front. Now here's the doozy. If it crosses at 0, remember we don't write x minus 0. X minus 0 is just x. So to handle that one, you just put an x on the outside. That's it. And then for the -4, that would show up as x plus 4. We got 2 down. They're just going to get easier the more we practice them. So we got 2 more to go. Number 7, here it is. We're going to figure out our A first. So from there, let's see, how far do we need to go up before we go over 1? So here's over 1. See, it hits there. So that's up 1, 2, 3. So our A is going to be 3. our two intercepts, it crosses here at -1 and also -3. I think we're ready to go. Y equals, our A is 3. Parentheses, we could do the -3 first, it doesn't matter. That's going to show up as x plus 3. The -1 is going to show up as x plus 1. Oh my goodness, we did it! We've done it! Okay, last one. Don't be sad, we're almost done. If we're looking for our A, we start at the vertex. How far do we need to go up or down before we can go over 1? This is just down 1 over 1. So our A is going to equal -1. I see it crosses here at +3 and also +7. We're ready for the equation. Y equals, A is -1, we could just write that as a minus sign out in front, a negative. It's +3, so x minus 3. +7, x minus 7. Sadly, we have reached the end of the notes. I know. But you'll make it. Until next time.